Alright, let's hope we can do this. This recording properly. Yeah. So I just found out how I want to do this thing. This is the code that I want to use to write my preamble, and probably I want to use something completely invalid here. I want to use UIT max as an invalid value because 0 is a perfectly fine value to fix up with. So there's that. Let me now implement the two register math thing here. Did I use the same thing here when I wanted to store something in there? Did I say math IM? Or did I say load something? I said load MM32. Let's make this a math just to be consistent. I don't think I have the code anymore. So let me just quickly type it in. This is this. Just that you want to do math. And whoops, we have to insert the opcode for math here. And I don't quite remember it. Was it 89? Let me check. When I wanted to move OX4, I don't know, to EX. Then this is, no, B8, it's B8. Right, that was the one. B8, let me check if I have this B8 anywhere else. No, it's there. So this is math. Right, good. And it uses PC values where it can, just because. Now. Good. Now we want to do the two argument math. So the first argument rec R rec B all let's do is dest and source. And then let's check out what the thing was again. I think it was like for register to register, like, do I have a math EX? I should have. And this is CO. This is strange. How does CO look in hex? Hexadecimal dictionary com. and hex, right? On. Here is it. Hexadecimal. It's oh. So it seems that the last three are the source and the destination. So if I use ESP, I should have 101, 101 there. Let me check this. E4 should be 101, 101. Whoops. E4. Yeah, 100, 100. So it is literally this one is the destination, right? This one is the source. So I just have to end it with the destination and then shift the source up 3-bit. Yeah, and then end it with that. So this is also not too hard. This is just this is 89, or was it 98? It was 98. Alright. Code, IP. There we go. The opcode for the move. Then just code IP++. This is OB101 shifted up by 6. Ended with source register shifted up by 3. Ended with destination register. I think. And of course, the equal sign here. This is what we should have. So this looks pretty good, actually. And I have to figure out what those 1-1 stand for, but I think they're the... Are they not? They have something to do with the direction? Could that be this? Um... 98. Both have R encoding. And the 2 1s. Say which one it is. One is the direction and the other one is what? Ah, well, it doesn't matter. It really doesn't matter to me. Because so what? Now I have what I want. Yeah. So now I have the register to register move. So this should work now. This should work now. And I think it's time to do a test of this. Alright, we have to do this. Alright. First we say with x86 BCGen. Is this how we called it? We called it x86 gen. How's the LVM backend called? It's called LVM BC gen. So yeah, I guess we call this x86. Let's call this BC gen as well, just for this is our gen. We have to call gen.initialize. Well, we can do the with statement here, not which, with. Now. And we say initialize. First we probably do this. Initialize. Initialize. There we go. And then we do yeah. Give me some time to think. Then we do an add. Yeah, let's do begin function. Begin function. And then we do we don't want to generate a parameter just yet. We just want to add 3. And the result is implicit. This is how we do this. This is safe to wherever. Or yeah, or just update the flags and don't save the result. Just leave it on the flags. Yeah, this is then we want to add an IMM32 to the IMM32, or let's say 3 to 5. And then we say we are done. I think. And I guess this concludes our function. Yes. This does indeed conclude our function. And we say finalize. And when we're done with it, we want to return the dump. And for now we don't do static assert. We do a pragma message. There we go. Pragma MSG. That's that. And I think we can compile this. Do we even include our x86 backend? I'm pretty sure something there is fishy. DMD, CTFE, PC, x86 backend. We of course have to say include source DMD, include source. Begin function. It's not callable using argument types because we don't have a default value here. We don't have a dump defined. I was pretty sure we had a dump defined. It's right here. Oh yeah, because we are not in the with some anymore. Have to do this. Need this for the address of function state 57. Yeah, so I can't initialize it to that. I guess this has to be done. After this, maybe this is the first thing we do. Undefined identifier function state. Don't I have the function states anymore? Oh yeah, this one is the current. Alright. And this one is called functions. So that's what the function states. Oh yeah, because the functions are called function states there. Yeah, I think I can call them functions. Maybe. And if I identify function set 62. For now, they can be called functions. Seems to compile and to take a very, very, very long time because I do the clearing. usual max to the other two. This is way too much to clear to number. There it actually says it's too much. So we didn't this basically means we overstep our bounds. And we try to do this actually. And this is because we started 4 there. But the clearing actually has to take effect on the whole thing. So there. Sub mm32 takes a BC value when it should take a normal uint, or maybe not. Like I could do this and we'd be fine. Can a correct expression 80R to U byte? Can't you just trust me that this is a U byte? Well, obviously you can't. Yes, you can't also trust me on this. Now you can. There we go. Here you will need to do this. Have to do the same. And here as well. Oh, is it because that the OXB8 is not typed as a U byte? And the R is not typed as a U byte? Like when I do this, you don't complain anymore. I can't modify a const expression. Code is const. And why is this a const function? Why is 1 a2 const? Well, it isn't const, but it's no GC, although that it really doesn't matter. End result is no stack value. That would be true. Because truly result type 5 is false. Yeah, that would also be true because it has no real thing, no real result. Yeah, this is no functions. In functions, no return segment, but expects. So the and oops, and function does expect to return something. Let's return basic function.init for now. Finalize cannot be interpreted at compile time because it has no available source code. It's true for now. It's this. So we have 85, 127, 168. We have the wrong. We used the wrong function identifier here. And we don't do, we don't need the cast anymore because now we type the register as 2 bytes. So it's all fine. That's pretty great. Those costs were ugly as hell. And now they're no longer needed. Great. Not sure if I can this one without a cost, though. I don't think so. So now they should work. And we should get this array maybe as a hex constant. And I think we can even do that. I think we can do like, I think format was CTFE-able. Percent X or like can we do like S hex? Then we call it again like that, and this is just string as hex. Takes the U with array. R. Like that. It just does for each byte in R. And of course we have the result here. Or I actually do disassembling function and make sure that this equals what I expect it to equal. But for now, let's just print it as hex. So this is just result. Okay, that equals. This is a byte. I want to get the lower nibble. And I want to do F A 0 plus yeah, right, I have to do yeah, so first I do OX. There we go. And then I have to convert this, so auto N1 or a lower nibble equals B and OXF. And then I do if ln greater than 9, do result. Yeah, result. Okay, equals do A plus ln, otherwise do 0 plus ln. Yeah, that's what I want to do. And I want to do this 2 times. One for the low nibble, one for the high nibble, yeah, which will be OXFO, and then shift it down by 4, I think I have to put parents around this. Whoops. Then this will be the iChain. And I could make this a little bit easy on myself and just say string. This is a string, the result here. String result. And the the length of that string is actually constant. It's r dot length plus times 4. Actually not 4, actually 6. No, 4, no 6. Minus 2. Yeah. Because what you can do is... Yeah, and we need the index. We need the byte and the index. And then this becomes result of I to I times I think I times 6, yes. No, I times 6 plus 2 is that. But that's a slice assignment, so expensive. So maybe I won't do this. And just do this. And this, then would just be this. And instead of result concatenate equals, I just say plus 2. Yeah. And then I do this, just do plus 3 here. And do the same on the high nibble, which I did on the low nibble. So that is that. And of course, the result has to be added with the 4 and 5, which is just the comma and the space after. Yeah. And there's that. And that can just allocate a constant number, put the things in. It's much more efficient than your usual CTFE concatenate everything everywhere crap. So this returns a result. This should work. 255. What's going on there? I do not understand why this won't work. Yeah, we have to cast this too. UN. Okay, now this should work. Oh yeah, I forgot semicolon. I don't know what this thing is talking about. Really? Oh, fork. I want a for each. Function expected, not as x. Type string. Immutable expression. Two, 5, 7. I do not know why it would think that result is an immutable thing. Do I have to make the car right for this? Yeah, it seems to be that way. And it wants to be cast to car, which is also understandable. Whoops, 252, I think. There. Yeah, okay. I can do this for you. So you don't have to feel bad about compiling something you don't want to compile. Yeah, OX55 is fine. OX98 is fine. OX50 is probably fine. And OX92 is just completely wrong. I don't know how we get this. I don't know how we ever get there. Or 8L, this doesn't make any sense. Doesn't make any sense. So yeah, it seems like we have to test our S-hex thing static assert. I guess we could just do pragma message S-hex. Then we use some just OXFFF, which should give us a same as output if we didn't mess anything up. And it says PPPP, which is wrong. Does it do anything right? I'm pretty sure we mess up when we come to anything that's bigger than to hex. Was it as hex? Yeah, right. Hex string. Oh, don't really matter. So when when ln is bigger than 9, we have to compute a minus 9. Whatever a minus 9 is. This one. Because we already have the 9 there. And because this is a constant, it should be constant folded. And we don't have to care about this. Then it should work fine. But it doesn't. It still says G instead of F, so minus 9. We have to make this minus 10, I guess. Yeah, so 10 is properly seen as 0. And now this looks much more like something we would actually want to have. So let's do stack assert. S hex equals ox ff comma ox ff comma this, right? And having this extra here doesn't hurt anyone. We could, if we wanted to, we could slice it out. And maybe we want to, so this would be this then. But really it doesn't matter, right? So now, this is... And you had a nice exercise of how you should write your CTFE functions. Actually, that for each does a bunch of temporaries, but hopefully they won't be too bad. So it should be fine. And let's now look if this is something we could conceivably generate to do this. And I don't know. This might as well be completely messed up. Let's paste it into our online decompiler. I guess we have this one here as well. It says something went wrong. I don't like this. Push EPB. Then there's an OR. Like what the? It reads the zeros as zeros, that's the problem. Well, we can remove those. It could really look for the patterns, pattern OX. This doesn't fill me with confidence. We must miss something out there. We do 98 when we should do 89. Maybe that's it. Yeah, and then we have completely wrong. Or actually, let me... Maybe we flip the high level and the low nibble. Because the high nibble should come first. And then the low nibble. So we flip those. Yeah, that's it. So this was just a mistake in our function because we didn't have a very good test case. Like, of course, this 55 looked fine because it doesn't matter if you flip the nibbles there. Okay. Yeah, if we now compile this again and paste on U literal in there, it should look better. And of course we need to take care of removing those. I don't know if we just want to remove those in our printing function for now. To as hex. Let's just instead of doing OX, let's do just X. Yes. And then of course the stack aside fails, but who cares? This is something we can now paste in the crappy online disassembler here. And here we have our preamble here with the push EPB, and then we sub. Oh, we sub of the wrong thing. We want to do it from the stack pointer, but we take EAX. That's not good. We forgot to OR in the register. It seems like good that we test this, right? Let's see what's going on there. Sub. We do OR in the register. Could it be that we passed the wrong register? We pass ESP, alright. So I don't know what's going on here. The math seems to be correct, alright. Where's the sub? Yeah, the sub totally looks like the register is not ORed in. Sub. Let's use a value which I can more easily recognize. Let's just 4 in here. It says 2D XO4, which should be sub X4. That should be sub EX4. And it is. And if we use the oh yeah, I see what's wrong there. We cannot just end it. We have to do a plus here. Here we can end it. Here we can't. Yeah, because the AND only works with the one that AND on 0. Right? Very, very good that we whoops, we don't need the cast here. I mean, this is something with the AND would totally work because we AND on 0. But do we want to keep this useless optimization or don't we? It doesn't really matter. No, the AND should always work because the lower 3-bit should be zeroed. Like in OD, we should also have the lower 3-bit zeroed. So ending it should work. Well, let's see if this works first. One, 5, 7. So this one. Cast Cuba. And the not is something we don't use. The move immediate is something we do use. But I feel like ending should have been alright. We shouldn't need to do plus because that should be the same in this case. So I don't know if we maybe make another mistake there. Or if one of my assumptions is simply faulty. Who knows? Yeah, so this should work. that says 2D plus 4, right? So it is as if we would never ever add the actual thing in. This is very strange. But let's copy the string and see what our disassembler says. So we push it, this move here is done correctly. The sub here is not done correctly. And we miss one set of zeros here for it to be correct. There. And we should have pasted a constant there, which we didn't do. So I don't know what's going on here. Oh, because we write the we write the constant without writing the opcode. The opcode is simply so now we do have the opcode for the add thing. No, the opcode for the add was OX5, right? Yeah, so we have to do oh no, right, we had our own convenience for that. It was at M32 and the register was rec EAX and the value is RHS. Right? That should now totally work and give us 3 plus 5. So we paste it, disassemble it, and we have 3 plus 5. Hey, nice! The only thing we need to fix here now is the subtraction of the stack pointer. And it almost seems to me as if ESP is 0. And we can certainly check that by doing something, in our preamble. Here. We can do... No, ESP is not 0. But we could certainly do this. If ESP would be 0, then we wouldn't have push ESP there. ESP is most definitely 4. Now we have those. Oh, so nice to have my own nice way of writing assembly. It looks so nice. I like it. Well, push. There we go. Yeah. So Something has to be wrong with the sub mm. Sub mm32 thing. Because it doesn't seem to add in the register at all. Oh, and I didn't do the cost. U byte and plus there, right? So maybe now it'll do it. Well, it looks different. And it has 31 in there now. And maybe it will actually subtract it from ESP. If we are lucky. Oh no, it doesn't. It doesn't XOR. Okay. So I was dumb then? Then tell me, what should sub from ESP be? Please. What is a sub ESP 0x4? What is it? Assemble it for me. Is an 83 EC. And EAX is what? It's 83 E8. Sub 32. So I don't know what's going on there. So it's 83 and then E8. E8 plus rec. E8. Yeah, and I guess I can just end it. So all this crap for nothing again. Just because I couldn't read my... And this is actually important that this is rather cheap. Because we want to do fast code generation, right? So, yeah. Let's do that. And so that's that. And I'm no longer sure how valid the OR is. But oh well. So now let's take this one. And let's hope it actually does what we think it should. So now this subtracts 4 from the ESP just as it should. But then there's another thing that does the wrong thing. And it's not wrong. And I don't know why. Because those 3 zeros are meant to be counted here. Right? But this subtraction is this the byte version for subtraction? I almost think so. So sub ESP. Let's do 266 here. Dollar. Do I have to do dollar for immediate? Like that, maybe. Or was it percent? Or I have to do comma. Alright, a comma. Then 266. And 466. And after 81 ECD2 E1 so 81 EC selects the stack putter. I wanna do just 4. It has 83 EC. So if I take 7. So this is the byte version. If I take 255, it would probably also take the 83. Two 4 maybe. Only up to 127. Yeah, up to 127. 128 is not handled by that. It is 128 and 1. 129. Is 81 EC. So 81 EC is the thing I need for things that are bigger than for like 4. So that's that. Yeah, but this has to do with the size bits that are set differently. Oh yeah, right, disassemble. Yeah, so this is an expensive way to encode this, but whatever, the encoding at least is consistent. And we have our add 3 plus 5 here. So this is great. And we can do SX. Maybe we'll just do H. Like this. Or maybe we do OX, I'm not sure. Maybe we do OX. X here. Then we do that. So now we figure this out. Yeah, so we can certainly produce smaller code, but this works for now, and well, it works for now. What can I say? So we can stop the recording and load it up.